In this tutorial, we're going to go over third-person movement, complete with animations, jumping, and running. I've gone ahead and set up a basic scene. For starters, we're just going to create an empty game object, make sure to reset its transform, and name it player. Later, we'll use a character model, but for now, we'll just use a temporary graphic. And it's just going to be a cylinder with adjusted sizes, and a little cube to tell which way it's facing. It's going to be important to remove both of their colliders in order for this to work later on. And before we make a new script, we're going to add the character controller component onto our player object, and then just adjust it to fit our graphic. Afterwards, we're going to have to create a new camera, because we actually already deleted the main camera out of the scene, because I don't like using main cameras anymore. And for now, we're just going to set it up to be able to see our character move around, and we'll worry about camera follow logic later. Once that's done, now we're going to create a new script called third-person movement. Quickly drag it onto our player, and then open it up in Visual Studio. The first thing here that we're going to do is make a reference to a character controller called controller, and then in the start function, we're just going to say controller equals get component character controller. After that, we're going to make a vector2 called movement, and then in the update function, we're going to say movement equals new vector2, parentheses input.getAxisRaw horizontal, comma, input.getAxisRaw vertical. Beneath that, we're going to say vector3 direction equals new vector3, parentheses movement.x, comma 0, comma movement.y, and parentheses dot normalized. We add the normalized, that way your character doesn't sprint when moving in a diagonal direction. Beneath that, we're going to say if direction.magnitude is greater than or equal to 0.1f, and controller.move, parentheses direction times, and then we'll have to go back up to the top and create a new public float called move speed, times move speed times time.delta time. Save that, and let's go back into the editor. Now if we test this, we should have our basic movement set up. Everything looks great, now it's time to get that camera movement. Exiting play mode, you should go to Window, Package Manager, go to Unity Registry, and install and download Cinemachine. After you have it downloaded, go to Game Object, Cinemachine, and create a new free look camera. And then we want it to follow our player and look at our cube, because that's where our head is at. And then for the top, middle, and bottom rig values, I would increase both their heights and their radiuses. And then by adjusting the y-axis value, you can see what it will look like in play mode. Speaking of play mode, once you have it where you like it, go ahead and test it out. Everything looks fine, but forward should really be the way the camera is facing. So with that, let's go back into our script. We're going to create a public transform, call it cam, and then beneath our character controller, we'll make a private float called turn smooth time, make it equal to 0.1f, and beneath that, another private float called turn smooth velocity. And then going into our if statement, we're going to say float called target angle equals mathf.tan2, parentheses direction.x, comma direction.z, and parentheses times mathf.rad2 degrees, plus cam.eulerangles.y. Under that, we're going to say float angle equals mathf.smooth damp angle, parentheses transform.eulerangles.y, comma target angle, comma ref, turn smooth velocity, comma turn smooth time, end parentheses. Beneath that, we're finally going to say transform.rotation equals quaternion.euler, parentheses 0f, comma angle, comma 0f, end parentheses. Now to set up our actual movement, we're going to say vector3, move directions equals quaternion.euler, parentheses 0f, comma target angle, comma 0f, end parentheses, times vector3 dot forward. Now all of that is fancy math to make sure that we're facing the right direction while we're moving smoothly. Now in the controller.move line, instead of direction, we're going to say move direction dot normalized. Save that and let's go test this out in play mode. And now we have smooth movement, and we're facing the right direction. Perfect. Now let's fix some minor things. If this wall was taller and we went behind it, we're not going to be able to see our character. On top of that, I don't really want to see the mouse in third-person view. So first off, we'll go to our Cinemachine camera, click Add Extension, Cinemachine Collider. And then for ignore tag, we're just going to say player, which is a layer that you're going to need to create and set this game object to. And then instead of preserve camera height, we're just going to pull the camera forward and increase the damping a little bit. Now going into the code just to get rid of the cursor, go into the start function. We're going to say cursor.lockState equals cursor.lockMode.locked and cursor.visible equals false. Save that and let's test this out. There you go. Now that that works great, let's go ahead and allow our character to run and jump. Back in our script, the first thing that we're going to do is replace move speed with a public float called walk speed, and beneath that, a public float called sprint speed, and finally, a private float called true speed. In the start function, make sure you set true speed to walk speed by default. Then in the update function, instead of move speed, let's set it to true speed. Then beneath the direction statement, let's say if input.getKeyDown, parentheses keycode.left shift, end parentheses, then true speed equals sprint speed. Beneath that, say if input.getKeyUp, keycode.left shift, then true speed equals walk speed. Save that and let's go back into the editor. Let's go ahead and set our walk and sprint values and then test it out. And now I can run and sprint. The next thing that we're going to focus on is falling and then jumping. Going back into our movement script. For starters, I'm just going to quickly move these 2 lines above our final if statement. Then let's go up to the top and organize a little more. Make a section for jumping, name this section movement, and then at the top, name this section essentials. Now in the jumping section, we're going to need a few things. We're going to make a public float called jump height, and then a public float called gravity. Beneath that, we're going to make a bool called isGrounded, and a vector3 called velocity. And then in the update function at the top, we're going to say isGrounded equals physics.checkSphere, parentheses transform.position, comma, 0.1f, comma, 1, and that 1 is the default layer, which is most game objects that you'll want to run on anyway. This is also why it's important that your player character with a collider on it is on a different layer. Otherwise, you'll just be able to jump into space. Now beneath this, we're going to say if isGrounded and velocity.y is less than 0, then velocity.y equals -1. Now going under the last if statement, we're going to say controller.move, parentheses velocity times time.delta time, and above that to actually use the gravity, we'll say velocity.y plus equals gravity times time.delta time. Now we should have falling set up. Save that, let's go back into the editor, and you'll see here that I've actually already adjusted the level a bit, and when we enter play mode and go off the edge, we fall right down. Now because of the way our player lines up with a camera, in order for it to fall at a reasonable speed, we have to make the gravity pretty intense. On top of that, if we stand on the edge when we're no longer grounded and then eventually jump off, we'll shoot to the ground at lightning speed. To fix those, as well as adding jump functionality, we'll go back into our script, and instead of plus equals gravity, we'll say parentheses gravity times 10 and parentheses. And then making our jump functionality above that, we'll say if input.getButtonDown, jump, and is grounded, then velocity.y equals mathf.square root, double parentheses, jump height times 10, and parentheses, times -2 times gravity, and parentheses. Now to fix that terminal velocity, we'll go beneath this, and we're going to say if velocity.y is greater than -20, so you can only fall as fast as -20, then we'll copy and paste in this line. And now we have terminal velocity. Now going back into the editor, let's go ahead and adjust some of these numbers. Now testing this out, we can now jump. We don't fall off the cliff at lightning speed. We fall properly, and we can sprint. That ticks every box except now it's time for a character model. Now we've already gone ahead and downloaded a Ybot, which we'll use to replace these 2 graphics, and all the animations that we're going to need. That being said, don't download any animations yet. We'll show you how to do that properly in just a second. After you replace the graphics with the character model, we're going to need to adjust the character controller. Once you set the character controller to the way that you like, you're still going to need something for the Cinemachine camera to look at. Now you could set it to the Ybot's head, but that might be moving around during the animation, so instead, create a new game object, just call it head, and move it roughly to the same spot. Now everything should be working about the same as it was before, so it's time to get those animations. Now if you go to our character rig model, it's already set to humanoid, and as opposed to copy from other, I set it to create from this model and hit apply. So now it has its own avatar. Now when you download a new animation from Mixamo or the asset store, make sure you set the rig to humanoid and you copy it from another avatar, the one that you just made. If you do that, your animation might look something like this, which despite the character staying in the same spot is the way that it's supposed to look, or if you set it to humanoid and don't copy it from your player's avatar, it will instead look like this. Half the time the hands are facing the wrong way, the knee is facing the wrong way, and the foot is facing the wrong way, and sometimes it just bends completely out of shape. And this animation isn't even that bad. So if you want good animations, make sure you download them properly. So for this tutorial, you're going to want a falling idle animation, an idle animation, a running animation, and a walking animation. Once you have those all downloaded, the first thing that we're going to want to do is create a new animation controller. I'm just going to name it player, go ahead and drag it onto our Ybot, and then let's drag in all of our animations. Once you got it set up roughly in this format, you're going to want to create a new bool parameter, call it isGrounded, the transition between any state and falling idle, then click on that transition, then go to settings, get rid of the exit time, make sure you turn it back off, and then set the transition duration to 0.125. Then go to conditions, and then hit new, it'll automatically put isGrounded, and then make sure it's equal to false. Now let's set up some more transitions. We're going to want one going from idle to walking, from walking to running, from running back to walking, and from walking back to idle. For these to work, we're going to create another parameter. This time it's going to be a float called speed. Now for each and every transition, get rid of the exit time and set the transition duration to 0.125. For all the transitions to walking, speed should be greater than 0.1, and for all transitions to sprinting, the speed should be greater than 1.1. Now for the transition from sprinting back to walking, make sure that speed is also less than 1.1. Anything to idle should have the speed less than 0.1, and anything away from falling idle should be isGrounded, as well as everything I just said. Once you're done, everything should look something like this. Now finally, we're going to head back into the script for the last time. Going up to the top at the bottom of Essentials, we're going to create a private animator called anim, and in the start function, we're going to say anim equals get component in children animator. Now beneath sprint speed, let's create a new bool called sprinting, and then going back into our update function in our sprint logic, beneath true speed equals sprint speed, say sprinting equals true, and beneath true speed equals walk speed, say sprinting equals false. Now at the end of this if statement, we're going to say if sprinting is equal to true, then anim.setFloat speed is 2, else anim.setFloat speed is 1. Say else anim.setFloat speed is 0. And then go under the is grounded statement and say anim.setBool is grounded is equal to is grounded. Now save that and let's test it out in play mode. Now it technically works, but you'll see that the more we move, the farther away the Ybot gets from the player object, despite it being a child object. This is because the animations for some reason move the game object's transform and rotation, which is pretty annoying. Now you should just fix the animations, but a quick fix is to go back into the script, go above movement and say anim.transform.localPosition equals vector3.0, and beneath that, anim.transform.local Euler angles equals vector3.0. Now save that, and we are done. Going back into play mode, you can run, you can jump, you can walk, you can stand still and look around, and everything is working. If you want access to the project files, they're only available to our patrons on Patreon, so go check that out if you're interested. Thank you so much for watching, and we'll see you next time.